Assalamu alaikum and welcome to the Mathcast with Faria Yusuf. And this video will be about binomial theorem. And after doing binomial expansion, we have the binomial theorem in which we have x plus y to the power n. We have the first term as x and then a plus y, x plus y to the power n, which equals n restriction 0, x to power n, y to power 0 plus n restriction 1, x to power n minus 1, y to power 1 plus n restriction 2, x to power n minus 2, this should be a 2 here, x to the power n minus 2 and a y square, so on up till we have n restriction n. And just remember, n restriction n is always equal to a 1. NCR, R equals n, NCN, that will be equal to a 1. X to power 0, that is also a 1, and we will be left only with y to the power n as the last term. This is called the binomial theorem, and we can also write it in the by the combination formula as x plus y to the power n, and this equals x to the power n. Now we can see that the first term here has the highest power, which is n, and then there will be the restriction which starts decreasing by 1, so that we have plus nc1 x to the power n minus 1 y to the power 1 plus nc2 x to the power n minus 2 y to the power 2 plus nc3 y to x to the power n minus 3 y to the power 3 plus continued terms up till we come to the final power of the second term as n, meaning it's y to the power cube here. One thing to remember and to note here is that the first term starts with the highest power n, ending with the second term as y to the power n here. So this should be y to the power n here. And then in between, I should be having all the terms so that the restriction is getting decreased by 1. Another thing to note about the restriction is if you have NC1, then you can see that the first x is getting reduced by 1 and the second y will be having the power, which is the restriction. NC2, so the first x shall be, or the first term here for the binomial expansion shall be for x to the power n minus 2, decrease the power decreased by 2, and the second term y will be having the power as the restriction. NC3, so the first term x reduced by 3 and y shall be having the power, which is for restriction, which is a 3 in this case, and so on up till we get NCN, which is a 1, x to the power 0, which is a 1, and then I will be left here only with y to the power n here. So this is the binomial theorem, and the term formula for this binomial theorem can be given as Tn, which equals Tr plus 1, which equals Ncr a to the power n minus r, where a is the first term here and b to the power r, which is the second term over here. So we will be doing some more examples to understand the topic clearly. Question 1. Find in ascending powers of x. In ascending powers of x, so I should underline this word. I need to have ascending powers of x. The expansion of 2 plus x by 5 to the power 5. So I have here 2 plus x divided by 5 to the power 5. N equals a 5. A is equals to a 2 and B shall be equal to an x by 5. Another thing to remember here is that if n is a 5, then the total number of terms in the expansion is going to be 5 plus 1, which is going to be a 6 here. So we know the expansion, we know the binomial theorem. This is x plus y to the power n, which is equals to x to the power n plus nc1, x to the power n minus 1, y to the power 1, and so on up till the final term here. So for this question, I'll be doing the complete expansion for the understanding. So if I have here 2 plus x by 5 to the power 5. I know my nth value, it's a 5 here. So I should say my first term is a 2. So I should say it should be a 2 to the power 5. Then it should be a 5c1, which is a 5. And then 2 here should be reduced as 5 minus 1, that is a 4. Y is an x by 5, and this is to the power 1, same as restriction. Then I have a 5c2. X here is a 2, and this is reduced by 5 minus 2, giving me a 3. And here I should be having x by 5 to the power 2 here, same as the restriction, plus 5c3 and 2 to the power 5 minus 3, that will give me a 2, and it's x by 5, that will give me a 3. And then I have a 5c4, 2 to the power 4, and x by 5 to the power, 2 to the power 5 minus 4, giving me a 1, and x by 5 to the power 1, and then it's x by 5 to the power of 5 only. So I can see I'm having 6 terms here: first, second, third, fourth, fifth, and then sixth. So I have my complete expansion. Let's just solve to get the answer. 2 to the power 5, that equals a 32. 5c1 is a 5. 2 to the power 4 is a 16 times x by 5. Plus 5c2, that's a 10. 2 cube is an 8. And then I should be having x squared divided by 25. Plus 5c3, which is also a 10. And 2 squared, that will give me a 4. And x cube divided by 5 cube, which is 125, plus 5c4, which is a 5, times 2 into x to the power 4 and 5 to the power 4. That shall be giving me 625, a 625 plus x5 divided by 5, meaning 5 to the power 5, that will give me a 3125. So solving it, the complete expansion shall be 32 plus this 5, it gets simplified, and I will here be left with 16x plus 80 divided by 25. So 80 divided by 25 shall be a 16 by 5 x square, and then plus 40 over 125. So 40 divided by 125, that should be an 8 divided by 25 x cube, and then I should be having a 10 divided by 625, which is going to be a 2 divided by 125 x to the power 4, and then finally I should be having x to the power 5 divided by 3125. So this is going to be the complete expansion of 2 plus x by 5 to the power 5 here. So this is how useful binomial theorem is, when we have to expand the terms in which a is having a value other than 1, and then we have a second term also, which is in this case 2 and an x by 5. This shall be giving us the complete answer for this question. So the second question says, find the first 3 terms in the expansion of 3 plus 2x to the power 8 here. So 3 plus 2x to the power 8 here, let's start solving for the expansion, and we can see here that it's 3 plus 2x to the power 8. My n value here is an 8. N value here is an 8. Therefore, starting the expansion, I should say that this shall be equal to 3 to the power 8 plus 8c1. Now, let's start reducing 3 by 1. So, this is 3 to the power 7, and I should be having 2x to the power 1. I can see here that 7 plus 1 shall be giving me the nth power, which is an 8 over here. Again repeating, restriction 1 has to be the power of the second term, which is 2x, and then reduced by 1, 8 minus 1, it should be 7 here. Expanding it more, I need the first 3 terms. I need the first 3 terms only. So going for the second term, I should say that this is 8c2 3 to the power 8 minus 2, which will give me a 6, and then 2x to the power square here. And then we don't want the other terms. So 3 to the power 8. So 3 to the power 8 is going to be 6561 plus 8c1 is an 8 times 3 to the power 7, that is going to be 2187 into 2x plus 8c2. So 8c2 is going to be a 28. So I have a 28 times 3 to the power 6, which shall be equal to a 729 times 2 square, that is a 4x square. And my final expansion is going to be 6561 plus 8 times 2187 times 2, and that will give me a 34992 x, and then it should be a 28 times 729 times 4, which will give me an 81648 x square, and so on. So this here is going to be the expansion for 3 plus 2x to the power 8 up till the first 3 terms. So this is how this question needs to be done. Let's quickly move to the third example, and for the find the first 3 terms in the expansion in descending powers of x of 2x minus 4 by 6. We have 2x minus 4 by x to the power 6 here. Now here I can see that my n is a 6, my n here is a 6, my a here is a 2x, and my second term here is a negative 4 by x. So I should be very careful with the second term because the sign here is a negative, and this is going to have an impact as discussed in the previous video. So start doing the expansion now. So if we start doing the expansion, I have 2x minus 4 by x to the power 6. Expanding it up till the 3 terms, I should say this is 2x to the power 6 plus 6c1, 2x to the power 6 minus 1, which is a 5, and then I will be having a negative 4 by x to the power 1 here. And then I should be having a 6c2, 2x to the power 4, and then negative 4x to the power square. So 2x to the power 6 shall be equal to a 64x to the power 6 plus 6 times 2 to the power 5. That will give me a 32x to the power 5 into negative. So I know that the second term had to be a negative. So it was a negative here, and then it's a 4 divided by x. And then 6c2. So 6c2 is going to be a 15 into 2 to the power 4, which is a 16 here, x to the power 4, negative 4 the whole square, that becomes a positive, giving me a 16, and this is x square. The question here has said that it should be descending powers, and we can see that if I solve for x5 divided by x, it's x to the power 4. X square and x4 solved, it's giving me x to the power square. Therefore, I can see that the powers here, they are in descending order. Therefore, this is 64 x to the power 6 minus 6 times 32 times 4. That will give 768 x to the power 4, and then it should be 3840 x square. So the expansion here of 2x minus 4 by x to the power 6 is equal to 64 x to the power 6 minus 768 x to the power 4 plus 3840 x square, which shall be the answer for this case. Let's determine the coefficient of x cube. In the expansion, I need the coefficient of x cubed. In the expansion of 1 plus 2x, now I need to have the expansion of 1 plus 2x and 2x minus 4 by x to the power 6. I already have the expansion of 2x minus 4 by x to the power 6. So I can say that here this is 1 plus 2x times 64x to the power 6 minus 768 x to the power 4 plus 3840 x squared. So if I want this expansion to get multiplied by 1 plus 2x so that I should be having a coefficient of x cubed, then in this case I should be saying that here if I multiply 2x by x square, 3840 x square, only then I will be having x, the coefficient of x cube. Otherwise I can see 1 multiplied by 64x6, that's not the coefficient of x cube. 1 multiplied by x to the power 4 coefficient, that's not giving me an x cube. And this term here is also not giving me an x cube. It's just 2x getting multiplied by the coefficient of x square. X into x square, that will give me an x cube. Therefore, I should say it's 2 should get multiplied by 3840. So here I should say that the coefficient of x cube shall be equal to 2x times 3840 x square, or I can say that this answer then is going to be 7680 x to the power cube, and this shall be my answer for this question. This shall be my answer for this question here. Find the term in y cube. Find the term in y cube in the expansion of 2 minus y to the power 6. So they are just asking for the term in y cube, therefore I do not have to do the complete expansion here. I'll simply use the term formula, which is Tn, that equals Tr plus 1, which equals NCr a to the power n minus r and Br. Applying the formula, applying the data here, my n value is a 6. My n value here, that needs to be a 6. N value here is a 6. So it's going to be 6cr 2 to the power 6 minus r, negative y to the power r here. And 6cr 2 to the power 6 minus r, I'm just writing this negative with a 1. So negative 1 to the power r, y to the power r. And here I know if my restriction comes out to be an odd number, then obviously the power with an odd number is always going to give us a negative sign. So with an odd power, with an odd restriction, obviously we shall be having a term with a negative sign here. So it's y to the power r, and it's just y which is the variable, and the question is asking here only for y cube. Therefore, here I know that my restriction should be a 3. Therefore, I can say that it is going to be a Tn, so that T4, my restriction has to be a 3. T4, because we know that it is Tr plus 1, so this needs to be a 3 plus 1, giving me the fourth term here. So it's the fourth term which shall be having y cube, and therefore I can see here that with r as a 3, it's going to be a 6c3 2 to the power 6 minus 3 and negative 1 to the power 3, and then y also to the power cube here. So 6c3 is a 20 into 2 to the power cube, and then I should be having a negative 1 and a y cube. So 20 into 2 to the power cube, that is an 8. That will give me the answer as a negative 160 y cube. So the coefficient here is going to be the fourth term, and this fourth term shall be having y cube with a coefficient of negative 160, which is going to be our answer for this case. Question 4. Find the term independent of x. We should be finding out the term which is independent of x in the expansion of x squared minus 2 by x to the power 6 here. So x square minus 2 by x to the power 6, meaning our n value here, should be equal to a 6. Independent of x means that it should be a constant, so that x should be having the power which is equal to a 0. So let's again apply the term formula. Instead of solving the entire question, we will be using the term formula, so that it's Tn, which shall be equal to NCr a to the power n minus r and br. N is, we do not know the term, so I'll be writing it as Tn, which shall be equal to Tr plus 1, and this shall be equal to n, which is a 6, Cr. A is an x square to the power 6 minus r, and then it's going to be a negative 2 by x to the power r here. Now I want the term which is independent of x, that means x should be having a power which is a 0. So here I will be having all my number values, which is a 6cr and a negative 2 to the power r on one side, and then solving for x, I should be having here x square to the power 6 minus r and 1 over x to the power r here. Solving only for x, I will be getting here x to the power 12 minus 2r, power to power. Here the power to power, they will get multiplied. So this becomes a 12 minus 2r into x to the power negative r. When the bases are the same, I can just simply add the powers. So I can say this is 12 minus 2r and a minus r here. I want x to the power 0 because the term should be independent of x. Therefore, x should be having the power as a 0. So I will be equating this to x to the power 0. Bases are the same, so this becomes 12 minus 3r, which shall be equal to a 0. From this equation, I will be finding out my restriction value, and I can say that it's 12, which is equals to 3r, or r, which is equals to 12 divided by 3, giving me a 4. So my restriction is a 4. My restriction value here is a 4. Therefore, my restriction value is a 4. Therefore, it's T4 plus 1. So I know it's going to be the fifth term, which shall be equal to 6C4 negative 2 to the power 4. And then obviously this is going to be x to the power 0. 6C4, that will give me the coefficient as a 15, and negative 2 to the power 4 being a positive power, being an even power, the negative will turn to a positive, giving me a 16 x to the power 0. So it's going to be 15 times 16, that is going to be a 240. 240 is the fifth term where this expansion is going to be independent of x here. So this is then going to be the answer. Question number 5. Find the coefficient of x cube in the expansion of 1 plus x minus 2x squared times x minus 2 by x to the power 7. So let's see how we can solve this question. We have 1 plus x minus 2x squared times x minus 2 by x to the power 7 here. Now they are specifically asking for the coefficient of x cube, which means here all the three terms should get multiplied by the expansion of x minus 2x by 7, giving the result for x to the power 3 here. So what I can see here is that if this 1 gets multiplied by a term which is having an x cube, only then I should be having a term in x cube with respect to 1 multiplied by a term with x cube in the expansion of x minus 2 by x to the power 7. Then what I can see here is that if this x gets multiplied by a term in the expansion of x minus 2 by x to the power 7 with the power as x square, with the power as x square, only then I will be getting an x cube here. And lastly, if my term negative 2x square gets multiplied by a term in the expansion of x minus 2 by x to the power 7, having the term in x, only then I shall be having x square into x, which shall give me a term in x cube. So these are the three terms in the expansion here. These are the three terms in the expansion of x minus 2 by x to the power 7, which I shall be wanting to have a term in x cube. So let's start working on it. So by the term formula for x minus 2 by x to the power 7, I know that the term formula says it has to be Tn, which equals to Tr plus 1, that equals NCr a to the power n minus r and b to the power r. In this case, I know the value of n. N here is a 7. I am doing the expansion, not really the expansion, but I am trying to find out the terms for the expansion of x minus 2 by x to the power 7 as the coefficient of x cube, x square, and x. So applying the formula, it's Tn, which is equals to 7Cr x to the power 7 minus r, negative 2 by x to the power r here. Taking the constant values on one side, I shall be having here 7Cr, which is equals to negative 2 to the power r, and then x to the power 7 minus r into 1 over x to the power r here. Or further, I can say that this x to the power r taken to the numerator will become x to the power negative r. So here I should be having the term Tn, which is equals to 7Cr. I don't have the restriction here, so it's 7Cr. Negative 2 to the power r, and solving for x, I should say it's 7 minus r giving me 7 minus 2r. Now let's start finding out the term for x cube. So for term for x cube, I should know that this 7 minus 2r shall be equal to x cube here. So if this shall be equal to x cube, then this becomes x minus 2r, which equals x cube, or equating the powers, it's 7 minus 2r, which is equals, or equating the powers, I should say this is 7 minus 2r, which is equals to 3, or 7 minus 3 equals to r, or it's 4, which is equals to 2r, therefore the restriction here comes out to be a 2. So if the restriction is a 2, then here in the term formula, now I can substitute this 2 and I can get the coefficient of x to the power cube here. So with r as 2, we know it has to be the third term. So if this needs to be at the third term, then I should say that it's T3, which shall be equal to 7C. Now the restriction is 2 into negative 2 to the power. I can substitute this r with the 2 then, and x to the power 7 minus 2 times 2. So 7C2 is a 21 times negative 2 to the power 2 into x to the power 3, or I can say that the third term here is 84x to the power. The third term here shall be 84x to the power cube here. The second term that I need to find out should have the coefficient of x squared. So to have this coefficient of x squared, I should be saying that it is x to the power 7 minus 2r, which equals an x square. 7 minus 2r equals a 2, or it's a 5, which equals a 2. And here I can see that the restriction is coming out in decimals. So when the restriction is coming out in decimals, it means that the term with x square does not exist. Meaning here for x and negative 2 by x in the expansion, when we get to solve this, the term in x square is not possible. So this is not possible over here. Then for the third term should be having the coefficient of x here. The third term should be a coefficient of x. Now to get this coefficient of x, I shall be again saying that it should be x to the power 7 minus 2r, which should be equal to x. This x meaning it should be having the power as 1. 7 minus 2r is equal to a 1, or I can say it's 7 minus 1, giving me a 6, which equals a 2r, or r here should be a 3. So if this r is a 3, then I should know that it's the fourth term. It should be the fourth term, so that the restriction is a 3. And again here I can say it's a 7c, restriction 3 times negative 2 to the power 3 and multiplied by x. 7c3 is a 35 times negative 8 and x, or I can say that the T4 here shall be equal to negative 280 x here. So I have the two terms which when get multiplied by the bracket, I should be getting, I have these two terms which when multiplied by 1 plus x minus 2x square, it should give me the coefficient of x cube. So to solving it further, I know that 1 should get multiplied by 84x cube, which is the term that we had over here, and then it should also get multiplied by negative 280x. So 1 getting multiplied by 84x cube and negative 2x square getting multiplied by negative 280x. With x, we know that there is no term in x square for the expansion here that can give me an x cube coefficient. Therefore, it's the product of 1 times 284x cube and negative 2x square times negative 280x here. So 1 times 84x cube is 84x cube negative 2x square into negative 280x, which shall be 84x cube plus 560x cube, and that is going to give us the answer, which is 644 x cube here. So this is how I should be getting the coefficient of x cube, which is 644. So this is the explanation for this question here. I hope you enjoyed watching the video and had a great learning. Thanks a lot for watching.